Hello everyone, welcome to lesson 8-3, Functions and Equations. In this lesson, we will continue to address the question, how are symbols such as less than, greater than, and equal to useful, as well as we're going to use the vocabulary linear function. So let's start by describing what a linear function is. A linear function is a function whose graph is a line. So remember that we talked in the previous lesson about functions or a rule, something that you must do to your input value, okay? A computation you do to your input value in order to generate an output. When we get a linear function, we actually get a straight line. When we put an x in, when we input our x, the function will make us get our y. And when we find those coordinates together on a graph, we will get a straight line. So what is linear? What does linear mean to you? To me, linear means having the form of or resembling a line. So essentially, a line. Anything that's linear is an adjective used to describe anything that resembles a line. What's the everyday definition of a function? Well, a function is a purpose, or we could say it is the purpose for which something is designed or exists for. So a function, I could ask you, what is the function of your car? Well, to take you from one place to another. What is the function of your pencil? To write. That's the function. What is the purpose of it? What do you notice about the graph? What do we notice about this graph right here? Well, it forms a straight line. You can see it right there. It forms a straight line. And finally, what is the math definition of function? In math, we say that it's a relationship that assigns exactly one output value to one input value. So as we were talking about, you put an input value and you will generate an output. Or you can say an output value is assigned to an input value, x and y. Let's see how this applies to a real life scenario. I'm sure this looks familiar to many of you. This looks like a function table where we have our inputs and we generate an output. We have hours of babysitting. We can choose to babysit for just 1 hour and we generate $6. At 2 hours, we should generate double the amount, right? Because it's double the time. Double the amount would be 12. At triple the amount from the first one, triple 6 is 18. And then finally, after 4 hours, it should quadruple the amount to 24. You see, so here we have a linear relationship. It's a line. They both move proportionally. As it increases by 1 on this line, in this column, it's going to increase by 6 in this column. So there's a proportional relationship. Let's see, babysitting. The table shows the amount of money Carly earns based on the number of hours she babysits. Write a sentence that describes the relationship between the number of hours she babysits and her earnings. Well, I can see what she earns per hour. She earns $6 per hour. So I will write, she earns $6 for every hour she babysits. Number 2, does she earn the same amount each hour? Well, I see that she does because for every hour we increase 6. See, we go from 1 to 2, 6 to 12. Every single time we add an hour, we're going to add another $6. So we can say, yes, her earnings increase by the same amount for every hour she babysits. Let's look at our first key point for this lesson. Write an equation to represent a function. If you recall, we've talked about y equals mx plus b in class, and that's what we're going to look at here. You can use an equation to represent a function. The input, or the independent variable, often always represented by x, okay, represents the x value, and the output, or the dependent variable, represents the y value. An equation expresses the dependent variable in terms of the independent variable. So what we're saying is, whatever we choose x to be will change y, okay? So x is, we choose it. We can pick whatever number we want. And after it goes through the function, or the computation, it will generate or make our y value. So our y always depends on whatever x is. And we can see that in this example. When x is 1, y will be 9. When x is 2, y will be 18. When x is 3, y will be 27. So we see here that we increase each time simply by 1, and down here we're increasing each time by 9. So 1 is 9. When x is 1, y is 9. So we can write something along the lines that when we have an x value, we have to multiply it by 9 to get our y value. We can write it the other way, where we say y is equal to 9 times whatever x is. So see, for example, if x is 4, okay, we take our 4 and we put it in here. It's going to convert that into 4 times 9, which will give us 36, as you see right there. When 4 times 9 is 36. Write an equation to represent the function shown in the table. Okay, here's our function table. We have our inputs of x, and now this time they actually give us a column for our function and our output. Okay, this part is often missing. This is the part we have to figure out. And they did do it for us. 1 times 9, 2 times 9, 3 times 9, 4 times 9, 5 times 9, and there's our products. How can we represent this? This function can be represented as y equals 9 times x. Every time we have our x value, we multiply it by 9 and we get our y, as we did right here. If you think you got it, go ahead and pause the video for this example right here. Try it on your own and then play the video to check my answer. Pause now. Okay, I hope you paused the video. Let's take a look at the relationships. Here we have 1, 2, 3, 4, so it goes up by 1 each time here. And then we have 16, 32, 48, 64, 80. 1, to make the 1 into a 16, I would have to multiply by 16, right? So I would have something that looks like this, 16 times x, right? Because my 1 here will go here, and we go 1 times 16 equals 16, or my y right there, right? So let's see, does that work for the next column? 2, I put my 2 in here. 2 times 16 equals 32. Yep, it works. Does it work with 3? 3, put the 3 in here. 3 times 16 equals 48. Yes, it works. So down here, we're counting by 16s, while up here, we're counting by 1. So our equation should be the following. Okay, y equals 16 times x. Let's take a look at our second key point for this lesson. Here we have graph linear functions, right? And how the x and the y work. You can also graph a function. If the graph is a line, the function is then called a linear function or linear equation. When graphing the function, the input is the x-coordinate and the output is the y-coordinate. So our input is our x, and what we generate out is our y. And when we write it into sets of coordinates, we write x, y. Our x is always our horizontal value, and our y is always our vertical value. Our x is often called the domain, and our y is often called the range. Okay? So now let's practice taking our equations, okay, our linear equations, and graphing them. Here we have y equals 2x. So every time we have an x value, we're going to multiply it by 2, and that'll give us our y. Does that work? Let's see. 1 times 2 is 2. So our coordinates are 1 and 2. X being 1 and y being 2. 1, 2. When we have a 2, we put it through our function. So it becomes 2 times 2. We get 4. So our coordinates are 2 and 4. You see it right there, 2 and 4. Okay, and we can graph this. We simply graph it by starting at our origin, and we look at our x value first, right? Our x value for the first one right here is 1 and 2, right? 1 and 2. So you run before you rise. And then the next one is 2 and 4. So we go to 2 and all the way up to 4. And then we draw a straight line that goes through the origin because this is a proportional relationship. Let's try it here. We have y equals x plus 1. So every time we have an x value, we're simply going to add 1 to it, and that'll generate us our output. Okay? And then, and we can choose any input. You realize that, right? We choose this. So let's just say I were to make a quick table here, right? And I have my x, and I have my y. So I'm going to just simply choose some numbers. I'll choose 2, 4, 6. I just wanted to do those. I could also choose 1, 2, 3. I guess I made it a little harder for myself. Well, if I put the 2 in here, right? The first one, 2 plus 3 equals, 2 plus 1 equals 3. And then so that's now my y, because it becomes 2 plus 1 is 3. I put my 4 in there, and I get 4 plus 1 is 5. And 6 plus 1 is 7. So my sets of coordinates are 2 and 3, right? 4 and 5, and 6 and 7. So let's take those here, right? And we're going to write them here. We said that they were, oh, I already forgot. 2 and 3, right? 2 and 3, 4 and 5, yeah, and 6 and 7. Makes sense because we're only ever adding 1 to make it the y, to get the y. So in order to graph these, we take our x value first, and we go to 2, and then we go up to 3. There's our first dot right there. Our second one will be here, 4, 5. We go to 4, and we go all the way to 5. For our next one, we won't be able to graph it, simply because there's no room to graph it. So what we can do now is we write our line. But our line, as you can see, is not going to go through the 0, 0. Okay? And I'll explain why. I'll explain why in 1 second. Let me just draw my line. We have what we call a y-intercept of 1. Okay? My line's going to go through the 1. As you can see right there. You see that? It goes through the 1. Because my equation is y equals x plus 1. If x were 0, okay, no value, I still have a 1. My y still equals 1. So no matter what, when x is 0, my y is still 1 because I have a value. So I'm not starting at 0, 0. I'm starting at 0, 1. And this is what we call a y-intercept. It's intercepting the y-axis. Let's try C. For C, we can see that we also have, we're multiplying our x by 3. Then we also have a y-intercept. Because again, if x were 0, 0 times 3 is 0. But my y would still be 2, right? I do have a y-intercept. Let's choose our values for x again. This time I'll make it easier. This time I'll just go 1, 2, and 3. And we go ahead and put the 1 in here, right? So it becomes 3 times 1 plus 2, or 3 times 2 plus 2, right? For the second one, and then 3 times 3. Just replacing my variable, my x variable, plus 2. And I'm going to get, now, 3 times 1 is 3, plus 2 is 5. So when x is 1, y is 5. 3 times 2 is 6, plus 2 is 8. And 3 times 3 is 9, plus 2 is 11. Okay, and there's my coordinates. 1, 5. I'll write them here first. I've got my x is 1 when my y is 5. When my x is 2, my y is 8. When my x is 3, my y is 11. Okay, I'm just simply copying this over here. Now I can go ahead and graph. Okay, I've got, let me straighten that out a little bit. I've got 1 and 5. I go to 1 and 5 all the way up there. Okay, 2 and 8 and so on. I cannot graph these. Okay, will I have a 0, 0? No, I do not go through 0, 0 because when x is 0, y is still 2. So that's another coordinate that I could add on there. When x is 0, y is 2. So why don't I go ahead and just put that in there, right there, right? Because x is 0, but I still go up to 2. And I can go ahead now and draw my line, and I see that I have a y-intercept of 2. It's not a proportional relationship. It doesn't go through the 0, 0. It starts at 2. So it's like, let me give you an example of where this would apply. Let's pretend these are hours down here. And let's just pretend to rent a bicycle, you have to pay $3 per hour. Okay, $3 per hour. So after the first hour, you would think you would pay 3. But just to borrow the bicycle without using it at all for any amount of time, you have to pay 2. So you pay $2, you get the bicycle. And then it's going to be $3 after that. Okay? $3 per hour after that. So you first pay the 2, and you haven't used the bicycle. You've used the bicycle for 0 amount of time, but you pay $2. Right? And then you use it for 1 hour, and now you're up to $5 in expending. If you use it for another hour, you go all the way up to $8, as it says here. See, 2 hours, $8. 3 hours, $11. Okay, that's a real world scenario there. Okay, and here's 2 examples, real world examples on how this is used, this method is used. We can see here that we have inputs and outputs, okay, and for example 4, we also have a plus b. You see, you multiply your x times 2 and you have a plus b, or what we say a y-intercept. For the sake of time, so I don't make this video so long, please pause the video and read through both of these examples and make sense of it. And if you have any questions, ask me in class. Let's go to the other question where we actually have to complete it. Here's our last example before our guided practice. Okay, let's read it. The graph shows the total amount y, okay, so total amount is y, that you spend if you buy 1 book, okay, books are being represented by x's, so number of magazines or books, okay, right here, 1 book and 0, okay, no, so we have books, but we have x magazines, so magazines is being measured by x, whatever we choose, and then we have the total amount that we have to pay, okay. Make a function table for the input-output values. Write an equation from the graph that could be used to find the total amount of y if you buy 1 book and x number of magazines. So if we buy 1 book and x number of magazines is our variable, it's our independent variable. Let's just pick some numbers. Let's just say I buy 1 magazine, or I buy 2 magazines, or 3 magazines, or 4 magazines. You see how we can just pick our independent variable? Okay. Now we have to figure out what our function is. What do I do to my x to make it my y? Well, in order for us to know this, we have to look at this graph very carefully. I'm going to zoom in and show you. Okay. Let's look at the difference between 2 points. Okay. We see here that when we have 1, we get 20. When we have 2, we get between 20 and 30, which is 25. Right? At 3, we get 30. So it looks like here, when we increase by 1, over here we're increasing by 5. See? 20, 25, 30, 35, 40 would be the next one, right? We could even put it there if we wanted to, 40. But, so that means that once I go down 1 more, if I go down here by 1, I should go down here by 5. So I'm going to go down to 15. You see that? That'll be my 15. So I have a y-intercept of 15. So I already know that in my equation, I'm going to have a plus 15. I have a plus 15. I'm starting at 15. So my y is going to be 15 no matter what, when my x is 0. But what is my x? Well, my x looks like it's an increase of 5 each time I choose a new magazine, another magazine. So I'll have a change of 5 per magazine. Do you see how I wrote that out? For every magazine, I'm going to multiply it by 5 so I can continue to increase. One magazine is 20 because it's 15 plus 5. 1 times 5. Two magazines would be 25 because 2, right here, if I put a magazine here, 2 times 5 is 10 plus 15 is 25. And there's our equation, everybody. Okay? Now, I'm not expecting you to be a master of this right away, but we will practice this in class, and I think you have a good heads up on what it is that we have to do. So again, we said when you only have one magazine, it's going to be 20. When you have 2 magazines, it'll be 25. 3 magazines, it'll be 30, right? Because each magazine is 5, so that gives me 15, plus another 15 gives me 30. And then 4 magazines will be 35, as you can see it right there. Okay, that's it for today's lesson. Please take a look at the guided practice. Make sure you feel comfortable with it. And if you have any questions about it, bring those questions to class. See you then.